Alright, so this is assignment 2, Dance Battle. I'm writing this in Python. Test case 1, we print out all of the moves in the entire match and then a win. Run it again. Test case 2, it waits a moment, or works for a moment, prints out all the things, it's labeling them as who's doing the moves, and then prints out lose. I can run test case 3, but it does not execute, or it does not finish, but I'm an undergrad, so that wasn't required. So we'll halt that. So if you look in the code, it's all in one file. The bottom is the main code. Down here, doing some UI stuff, or the interaction stuff, and then we read in problem. So that's this function here. I'm reading all the input, and then I'm creating a list of input turns. So that's the list of turns that have been done, and then returning a problem object from that. And that problem object is described up here. Takes in n and m and the input turns, and then processes the input turns and turns them into that 2D array of bools, and that's this used turns. And it figures out what the last turn was and saves that as a member, and then creates a dance state as the initial state with the whose turn it is, what the last turn was, and that 2D array of bools. And those dance states are what's going to end up being in the tree that's created. So if we look at what's in a dance state, it has whose turn is it, what the turn is that's being done, what the last move in the turn is, just for convenience, and then the 2D array of what has been used so far. So if we go back to the main code here, so I create a problem object, and then create a node from the initial state, then I expand, then I evaluate, and I get the evaluation number, and then at the end I'm just printing everything out. So let's look at that expand and evaluate. Those are on nodes. Node just takes in the data, which is the dance state, the parent, and then children, starts empty. Expand creates the whole tree, so it iterates through that used turns list and figures out what's available, and then creates children where they can be created, and then expands those children recursively when it can. So that expands the whole tree. Now if we it creates the children in here and just creates a new state. It marks all the marks the turn that's been done, creates the turn that's being done, changes whose turn it was, blah blah blah. And the evaluate is where the min-max algorithm is. And again, this is done recursively starting from the root. So if it has no children, then it's a leaf node. So if it's my turn and it's a leaf node, that means that min cannot make any moves, so return 1 as the win case. If it's a leaf node and it's not my turn, then min wins because min has the last move. So it's going recursively down to all the children. Then when it gets to a leaf node, that's what it returns. So this is the case for if it does have children. If it is my turn, then, or if it's not my turn, then we're looking for the max because I'm going next. So here we are, iterate through the children, figure out which one has the maximum value, save off which child we've chosen, so that way we can print it off later, and return max value of the children as your evaluation. Then on here we're doing the min, and it's just all the opposite, so we're returning the minimum value. And I think that's everything.